We spent a lot of time in class on building the unit circle and starting to learn how to use it to evaluate trig functions. So this podcast is just going to be a review of building the unit circle and using it to evaluate trig functions. First thing we're going to look at is actually building our circle. And what we start off with is graphing the equation x squared plus y squared equals 1. So this is a circle that is centered at the origin and has a radius r equal to 1. So that means this point out here is the point 1, 0. Up here we have 0, 1, negative 1, 0, and 0, negative 1. Now remember, we can think about wrapping a number line around our circle, and anytime we create an angle with a measure of theta radians, that means we've traveled a distance along our unit circle of t. And for every single t, we have a point on the circle, xy. Now we can also do rotations that are clockwise. So these will have negative values of theta, and your t value is going to be less than 0 because you're going backwards. And up here we're going forwards, which is counterclockwise. And so our t values are all going to be greater than 0. And there is also another point xy that goes with that t down there. Let's review real quick the definitions of our 6 trig functions. First of all, we have t, which is a real number, and that is the distance that we've traveled, which corresponds to our the measure of that angle, theta, in radians. So t is real, and it has a corresponding point on our unit circle, xy. Okay, therefore, we can write out our trig functions. Recall sine of t is equal to y. Cosine of t is going to be equal to x. And tangent of t is going to equal, remember tangent is sine divided by cosine, so that's y over x. And then we have our 3 reciprocal functions. And that is cosecant, which is 1 over sine. So that's 1 over y. And so that it's defined, y cannot be 0. And we've also got secant, which is going to be equal to 1 over cosine, which is 1 over x. X cannot be 0. Oh, and I forgot to put that with tangent up here. X can't be 0 up there either. And then we have the cotangent, which is 1 over tangent. So we just flip the tangent over. We have x over y, and y does not equal 0. One last thing to notice here. If you look, y is always between 1 and -1, and so is x. So that means that the range for sine and cosine is -1 to 1. So if you get a value that's bigger than +1 or smaller than -1, you better go back and check what you did, because you made a mistake. Okay, let's go on to a quick review of how we built the unit circle when it was divided into 8 pieces. So that means we've divided it into pi-fourths. Down here we've got 5 pi over 4 and 7 pi over 4. The way that we were able to set this up is by using the fact that this point here lies on the line y is equal to x. So if we just substitute this x in here for y, you get x squared plus x squared equals 1, which means 2x squared equals 1. X squared is 1/2. We take the square root of both sides. We're going to get 1 over the square root of 2. But remember, we can't have a square root in the denominator. So if we multiply the top and the bottom by square root of 2, we're going to get square root of 2 over 2. Since y and x are equal to each other, which we said right up here, then y is also square root of 2 over 2. So this point is the square root of 2 over 2, square root of 2 over 2. There's a really easy way now to get our remaining 3 points, and the way we do that is we use our quadrants. In quadrant 1, notice the signs on x and y are both positive. Over here in quadrant 2, well, x is going to be negative because we're to the left, but y is still going to be positive. Down here in quadrant 3, remember both negatives. And over here in quadrant 4, x is going to be positive, oops, should be a plus sign, and y is negative. So you could go through just like we did in class, and you just use this first quadrant point and fix the signs like we have them here. So this one is going to be negative square root of 2 over 2, negative square root of 2 over 2. Now if you missed class, be sure you pause this podcast and go through and fill in the other points on this circle so that you have those for a reference. Okay, let's do an example of how we can use these points. I've gone ahead and filled them in on this circle. And what we want to do is we want to find the exact values of all 6 trig functions when t is equal to 3 pi over 4. Go over to your unit circle and let's find 3 pi over 4 right over here. So we're going to use this point right here. Remember, this is x and this is y. So sine of 3 pi over 4, remember sine is equal to y, so that's going to be positive square root of 2 over 2. Okay, now let's look at cosine. And over here, x is negative, so that means cosine is negative square root of 2 over 2. Tangent, 3 pi over 4 is going to be sine divided by cosine, which is going to be the square root of 2 over 2 divided by negative square root of 2 over 2. These are just going to cancel out, so you're going to get negative 1. Now let's do the reciprocals. So cosecant of 3 pi over 4 is 1 over sine. So we flip over and we get 2 over square root of 2, but remember, we can't have that root in the bottom. So we multiply the top and bottom by square root of 2. And you end up with square root of 2. Okay, then we've got secant of 3 pi over 4, and that's going to equal 1 over cosine, and our cosine up there is negative square root of 2 over 2, so this one's going to be negative 2 over the square root of 2. But again, we've got that square root of 2 in the denominator, so we multiply top and bottom by square root of 2, and we're going to get negative square root of 2. Cotangent, last one, of 3 pi over 4 is 1 over tangent. 1 divided by negative 1 is still just negative 1. Okay, let's look at now how we built the unit circle for counting in pi 6. Now we've done this a couple times, so I'm just going to go ahead real quick and label these counting by sixths. We've done this a couple of times, so you should be able to do it pretty quickly. Now, we're going to see if we can figure out what this point is right here. If we drop a straight line down right here, you'll see that this corresponds to x equal to 1/2. So if we go ahead and substitute x equals 1/2 in our equation up here, you'll get 1/2 squared plus y squared is equal to 1. So that's 1/4 plus y squared equals 1, which means y squared is 3/4. Square root of both sides, you get square root of 3 over 2. So this point here is the square root of 3 over 2. Now the nice thing here about counting in sixths is if you look here at pi over 6, if we cut a straight line here, we'll pretend it's straight, now we've reversed it, and y is 1/2. So rather than going through this whole calculation again, we might as well just use the fact that x and y would be switched around, and we know that now x is square root of 3 over 2. And this is going to be true all the way around our circle, where the thirds and the sixths are the reverse of each other. And once again, we can use the knowledge of the signs and the quadrants to go ahead and fill in the rest of the information. So remember, Q1, positive, positive. Oops, Q2 is going to be negative, positive. Down here in quadrant 3, we're negative, negative. And over here in quadrant 4, we are positive and negative. So for example, 11 pi over 6, well, pi over 6, we have the square root of 3 over 2 first. And 1/2 comes second. And in this quadrant, we're okay with x because it's positive, but we got to put a negative on the 1/2 for this negative right down here. Again, if you did not do so in class, go ahead and pause the podcast right now and fill in the remaining coordinates for the thirds and the rest of the sixths. Okay, let's practice a little bit using our unit circle to evaluate one of the thirds. Let's look at t equals minus 2 pi thirds. So if we go to our unit circle, we now know we're going to be going this direction because t is saying it's negative. So here's minus 1/3, and here is minus 2/3. So this is coterminal with 4 pi over 3. Okay, so the point that we're going to be using is right here. We've got our x and our y. And let's go ahead and figure out what our 6 trig functions are using x equals negative 1/2 and y equals square root of 3 over 2. Start off with sine of negative 2 pi thirds, and that's going to be y, which is square root of 3 over 2. Cosine of negative 2 pi thirds is going to be x, which is negative 1/2. Tangent, again, is sine divided by cosine. So we've got square root of 3 over 2 divided by 1/2. Well, they're both over 2, so those 2's, let's cancel those. And we're just left with square root of 3 over 1, or square root of 3. Okay, now let's do our reciprocal functions. We'll start off with cosecant. Now, whenever I deal with the reciprocals, I always like to write it out in terms of the original function. It helps me to not make as many mistakes. So I'm going to remind myself that cosecant is 1 over the sine of negative 2 pi over 3. So I'm going to take the reciprocal of sine, which is going to be 2 over the square root of 3. But just like before, we can't have that root 3 in the denominator. So we multiply the top and bottom by square root of 3. Sorry, it got a little squished in there. So we get 2 square root of 3 over 3. Moving on to secant. Again, I like to remind myself that this is 1 over cosine, and so I don't run out of room, I'm just going to put the parentheses there. So we've got 1 over cosine, so I flip over negative 1/2, and that gives me negative 2. Okay, last but not least, cotangent, negative 2 pi over 3 is equal to 1 over the tangent. So let's flip over square root of 3 over 1, and we get, we'll get 1 over the square root of 3. Multiply the top and bottom by square root of 3. And I get square root of 3 over 3. So those are all 6 trig functions for t equal to negative 2 pi over 3, which is coterminal with 4 pi thirds. Okay, the last thing that I want to review for this podcast is using the period of the functions to help you evaluate them. And what that means is that once we make a revolution all the way around our circle, the values start to repeat. So if I start here at t equals pi over 4, if I go all the way around one time, I'm right back at the same point on the circle. I've just gone around an extra time. So that means that t equal to pi fourths is going to have the same value as t equal to pi over 4 plus 2 pi. Same thing's true up here with pi halves. So pi over 2 plus 2 pi is going to be corresponding to the exact same point. So let's test this out and see what it actually looks like. Let's say we have sine of 5 pi. Well, I go around the circle once, that's 2 pi. If I go around it again, that's 4 pi. I need to go 1 pi further in order to get to 5 pi, which is going to correspond to pi. So this is equal to sine of 4 pi plus pi, which is equal to sine of pi. And over here, sine is 0. Okay, a little harder one. How about if we try cosine of negative 17 pi fourths? And I'm not going to draw in the circle again because it's getting to be a crazy spiral over there. So one thing I can look at is, okay, 4 goes into 17 4 times. So I have cosine of negative 4 pi. Negative 4 times 4 gives me negative 16. I'm going to have to go 1 more pi over 4. But it's going to be a minus pi fourths because I want to get to minus 17. So this is the same as cosine of minus pi fourths because we can eliminate this multiple of 2 pi right here. So cosine of minus pi over 4 is going to correspond to this point down here. But notice, if I draw a line like this, pi fourths and minus pi over 4 have the exact same x value. So this is also equal to cosine of pi fourths. And right there, it is square root of 2 over 2. And you can look back in your notes to see that on your unit circle that we created earlier. Okay, last thing, here we go. It's your turn to try and evaluate all 6 trig functions using the given information. So you've got things presented to you in a couple different ways. We've done problems like this in class. If you need to, go back and check the podcast for some more help. Okay, great job everybody. I hope this review helped. And we look forward to seeing you in class.